Alright, our song today is The Boys of Summer by Don Henley, and our topic is solving compound inequalities. A compound inequality is when you have more than one inequality in the same statement. And we're also going to be taking a look at absolute value equations and inequalities as well. A couple of vocab terms. Our first one is a disjunction. This is a compound inequality that uses the word or. And you will literally see the word or in your statement. You'll have two inequalities with the word or in between them. And it is true if and only if, hopefully you guys have seen that abbreviation before, it is true if and only if at least one of its parts is true. So the first inequality could be true, but not the second. The second could be true, but not the first, or they can both be true. So we have a lot of options to make a true statement with a disjunction. When you graph it, you will graph the solution to both inequalities on the same number line. And some keywords would be all or everything. Our second type of compound inequality is a conjunction. And this will use the word and. You may or may not see the word and. You may just see a string of inequalities linked together. A conjunction is true if and only if all of its parts are true. So every piece of the inequality statement must be true. And the intersection means you only graph what makes both inequalities true. Some keywords would be overlap and common. And finally, our absolute value inequalities. These turn into a compound inequality, and it's going to be our job to figure out if it's a conjunction or a disjunction. We have to figure out if we're going to use the word or and. I have a little trick to remembering this, but I want to make sure you know why it works before I give you the trick. And also I'm going to give you some time tonight to think about it and see if you can come up with your own way of remembering how it works. Alright, so we're going to start off with some basic compound inequalities. Our first inequality here is a conjunction. We don't see the word and, but we see a couple of inequalities all linked together. So to solve this, I need to isolate the variable. You could split it up into two different inequalities, or since we're in the Agri Prep class, we can think a little bit higher level, and whatever we do to one side, we do to all three sides. So I'm noticing I've got my variable in the middle. I want to isolate it, so I'm going to subtract 6 from all three parts. So negative 50 minus 6 in the center, that 6 cancels, and negative 8 minus 6. And then finally I'm going to divide everything by 7. So dividing through by a positive 7 leaves my inequalities facing the way that they are. I don't have to flip them. And now the way that this is set up is really nice because I've got my k in between negative 8 and negative 2. And think about removing the k. You'll see, so if I rewrite this without the k, you'll see that that is a true statement. Negative 8 is less than negative 2. So we can go ahead and graph this. Put that on a little bit. All right, and we've got the just less than symbols. So these are open circles because negative 8 and negative 2 will not make this inequality true. And k is in between, so we shade in between. So our next one is an or. So we solve each inequality separately and then graph both of them on the same number line. So my inequality on the left, I'm going to multiply both sides by 3. Subtract 7. Dividing by a positive 2 leaves my inequality facing the way that it is. Second one, I'm going to subtract 4. Oh, sorry, now that I'm looking at it a little more closely, I am actually going to add x to both sides and divide by 3. Now careful on this one that you notice the variable is kind of on the wrong side of the equal sign. X is greater than 4/3. If you want to, you can flip the entire inequality to make it look a little bit more normal and it might be a little easier to graph. Alright, so we're just going to graph both of these because whatever makes one inequality true makes the entire statement true. So 4/3 obviously is on the positive side. So that would be about here with an open circle. And then negative 2 is on my negative side. This one has a closed circle. It's an or equal to. x is less than or equal to -2, and x is greater than 4/3.